The best thing that you can do to make sure your podcast performs well with your audience is to make it good. Podcasting is still an area where quality really is rewarded, and making your podcast the best that it can be is probably the number one way to make sure that people hear it.
It is now time to explain to people just what's wrong with me. Yay!
The universe may be expanding, but that doesn't mean that objects within the universe aren't moving closer to one another. Despite the fact that things around us are stretching out at an ever-increasing rate, the Milky Way and Andromeda galaxies are on a collision course. What happens when two black holes collide? As cosmologist Tamara Davis explains in a Scientific American article, this is happening because the universe isn't governed by just one force. The entire universe might be expanding, but there are forces working at the galactic and intragalactic levels to counteract these effects, namely, gravity. In our neighborhood of the Milky Way, called the local group, the gravity attracting the Andromeda and Milky Way galaxies to one another is much greater than the universe-level forces that are pulling them apart, and it will lead to a galaxy collision. A new study in astronomy and astrophysics sheds light on the time frames during which all this will occur. It'll take about 4 to 5 billion years for the two galaxies to first meet, and eventually, the supermassive black holes at the center of both galaxies will collide. Collision doesn't happen in an instant. While collision may make this sound like a one-time event, the crashing together of two galaxies is a process that will actually take an incredibly long time. Science News notes that it will take a full 10 billion years for the two galaxies to completely merge into one massive elliptical galaxy, dubbed Milkomeda, by the paper's authors. Even after these two spiral galaxies have become one massive entity, the black holes at their respective centers still will not have touched. That's because there's a lot of empty space within galaxies, between stars and solar systems, and both these black holes are at the very center of the two galaxies and will meet at the tail end of the merger. In the paper, the authors report that the supermassive black holes at the center of the two galaxies will begin orbiting each other when the single Milkomeda galaxy emerges, in roughly 10 billion years. However, it will take another 7 billion years beyond that for the supermassive black holes to actually collide, because the velocity at which these black holes move toward one another is dependent on the mass of the stars close to each respective galactic center. More mass around the black holes means that the forces attracting these two objects together are stronger. Once these surrounding stars have been depleted by the black holes, the two will stall out. Eventually, though, there will be a spectacular galaxy collision. Invisible fireworks. But what happens when two black holes collide? When the cores of the Andromeda and Milky Way galaxies finally smash together, they will merge into one supermassive black hole. When that happens, it will be an absolutely phenomenal event that's completely invisible. There won't be any fireworks in the sky when it happens. That's because black holes are invisible to the naked eye. However, any intelligent civilization that exists at that point with capabilities that match our own will be able to detect the collision. It will send out absolutely massive gravitational waves detectable by an observatory like LIGO. It's important to note that the timing given here is all speculation based on modeling. There's still a lot of uncertainty because the data researchers are inputting into the model may change. It's hard to take into account the many factors at hand, such as the velocity at which the galaxies are speeding toward one another or the size of the galactic halos. As a result, the paper's authors make clear that these are rough estimates. Written by Swapna Krishna. The IDK theory. I came about this theory in my mind IDK, I don't know, as I was sitting there with plenty of time to spare pondering what if life is like and will be like in the future, and what happens to us. I started to wonder what would happen after we die. Then I started to think even further. I was thinking of alien civilization and what they might be like. Everything in between Planck life to the edge of the universe. And every time I got into deep thought I came back with the same inconclusive but inevitable answer, I don't know, hence IDK. Matter of fact, nobody else to a certain extent depending on the subject, but even then if you go down the rabbit hole. Neither you or me, the smartest people in the world, or even some of the most popular philosophers, will come back with, I don't know, because that is the plain hard truth, and that is where I came up with this theory. You can try to look at it in different ways with faith, hope or something else, but no matter how you look at it, the answer will always be I don't know IDK. No matter how far you push the human mind, the common eventuality will then always be IDK. I don't know if this makes any sense, but what I do know is that I would like for anybody to come back with an answer to change my mind or yours about this, and therefore, what the topic will be and always will be. IDK, I don't know, and that's very much okay for now. This was something I uploaded at the time on Wikipedia on my Wikipedia page. I did not really, nor truly understand everything at this time when I uploaded it. But since then I have created a podcast, made leaps and bounds in communication, also jumped a lot of hurdles through my own personal journey in life. Overcame certain aspects in my life, which used to define me. Last but not least, I can say with more confidence I do know more than I did when I wrote this. But that formidable foe, I don't know, will always be at the forefront and ending of each and every mystery, rabbit hole, black hole, white hole, and every road you go up or down, over or up, I don't know, will be at the forefront of mine and your life. Sincerely, Jimmy James, the host of the Jimmy James Show A to Z. And like always, take care of yourselves and one another.
Okay, I get it. Oh fuck, do I need that plugged in? You know, I always unplug the wrong wire. Alright, so yeah, I know I went on for like, I don't know, 15 minutes of me just rambling on about shit, but I really did want to get down to like the black holes in the universe. And I'm sitting there and I'm like, I've been into this shit for a long time. I want to know personally, how do we know black holes, like, you know, in the universe do what they do? So here's a once I stop it. So I figured, what the hell? This next bit on YouTube, this is all YouTube. This is not me. I figured I could put it in the robot thing and have it read to you. And I was like, it's not that great. So here you go. A minute in. We're going to pause until I get the show up and running. The name of this is The Bizarre Nature of Black Holes, explained by Brian Greene. This was up, by the way, this is the closest one I can find, uploaded or published on October 16, 2021. So stay tuned. After this Anchor ad, sponsor Anchor, Stay tuned to hear their theory of how black holes are what they are. Here we go.
I believe there's a way. I believe there's a way, sir. I believe there's...
Alright, guys, here we go. I'll put the link below. The Bizarre Nature of Black Holes, explained by Brian Greene.
The Sloan Digital Sky Survey did a wonderful study of a vast number of galaxies. It seems to be a ubiquitous quality that black holes are at the center of galaxies, and those are typically gargantuan black holes, millions or billions of times the mass of the sun. Some have suggested that early stars, which were quite large compared to more modern stars, when they exhausted their nuclear fuel and they collapsed in on each other, they created black holes that were large, and then they continued to suck in more material from the environment. They grew larger and larger still. So that's sort of one rough way that people think about how these massive, enormous black holes may have formed, but it's uncertain. LIGO, this laser interferometer gravitational wave observatory, gravitational waves. It took headlines a few years ago when it detected the first ripples in the fabric of space. It detected them from two black holes that were 1.4 billion light years away, like 1.4 billion years ago, rotating around each other, going near the speed of light, slamming into each other, creating a tidal wave in the fabric of space that rippled outward at the speed of light. Part of it raced toward planet Earth. There wasn't anybody on planet Earth to see it at that moment, but it had 1.4 billion year journey to traverse. It raced toward planet Earth. When it's about 100,000 light years away, it grazes the Milky Way galaxy. It continues to race toward Earth. When it's 100 light years away, a guy named Albert Einstein writes down equations that suggest there could be these gravitational waves, unknown that one is already racing toward the planet, and it continues to race onward. 2 light days. It's 2 light days away when they turn on the newly refined version of the LIGO detector, and 2 days later that wave rolls by planet Earth, shakes the 2 detectors, one in Louisiana, the other in Washington State, giving us the first direct detection of ripples in the fabric of space. So these things are out there. And before the direct radio telescopic imagery from the Event Horizon Telescope of the black hole in M87, that ripple in the fabric of space was the most direct evidence that black holes are real, because when you took the way that the machine in Louisiana and Washington, it twitched for just, a tiny fraction of a second, when you figured out using supercomputers what the cause of the wave must have been, you are led to 2 black holes that are 28 and 31 times the mass of the sun. And that was the only explanation for the data. And so there's this beautiful indirect proof that these stellar-sized black holes are actually out there. And then, of course, we take a photograph of one in a nearby galaxy.
A black hole is one of the strangest and most fascinating objects in outer space. It is formed when a star with sufficient mass is dying. The gravity is so strong because matter has been squeezed into a tiny space that not even light can escape from it. A fascinating type which can reach up masses 20 times more than that of our sun are stellar black holes. However, their size is nothing compared to some of the enormous supermassive black holes with mass on the order of millions to billions of the times of the mass of the sun. Some astronomers have begun labeling black holes of at least 10 billion solar masses as ultramassive black holes. Most of these are associated with exceptionally energetic quasars. Even larger ones have been dubbed stupendously larger black holes with masses greater than 100 billion suns. However, black holes can be big or small and very counterintuitive. Some scientists think the smallest black holes are as small as just 1 atom. These black holes are very tiny but have the mass of a large mountain.
Oftentimes people think about black holes as these gargantuan structures that form from collapsed stars. There's a big one in the center of our Milky Way galaxy, weighs 4 million times that of the sun. The photograph of a black hole in the galaxy M87 that got the world excited a couple of years back, 55 million light years away, billions of times the mass of the sun. But the reality is, anything, if you compress it enough, becomes a black hole. If you take an orange and you squash an orange down sufficiently small, according to Einstein, it becomes a black hole. The flip side of it is we also typically have an intuition that black holes are really dense, right? That's usually the way we think about them. But if you make something sufficiently large, regardless of how low its density is, it will also become a black hole. So you can make a black hole out of air. If you have enough air, sufficiently large sphere of air, it would become a black hole too, with the density of air. So all the intuition
My show is a black hole spiraling out of control.
we typically have about black holes, that they have to be dense and they have to be gargantuan, not right.
In 1915, Albert Einstein developed his theory of general relativity, having earlier shown that gravity does influence light's motion. Only a few months later, Carl Schwarzschild found a solution to the Einstein field equations, which describes the gravitational field of a point mass and a spherical mass. Einstein himself wrongly thought black holes would not form because he held that the angular momentum of collapsing particles would stabilize their motion at some radius. This led the general relativity community to dismiss all results to the contrary for many years. However, a minority of relativists continued to contend that black holes were physical objects, and by the end of the 1960s, they had persuaded the majority of researchers in the field that there is no obstacle to the formation of an event horizon, a boundary in space-time through which matter and light can pass only inwards towards the mass of the black hole. Nothing, not even light, can escape from inside the event horizon.
And when you look at Einstein's equations, right in his mathematics, there's a little formula that you can see where it says if you have any mass m, whatever mass you want, and you squeeze it into a radius r that's less than 2 times Newton's constant 2g times m divided by c squared, speed of light squared.
Hold on, let me just write that down. Say that one more time.
A formula. Details don't matter. But you take any mass, if the radius within which that mass sits is less than 2gm over c squared, it is a black hole. Period.
2gm c. Gotcha.
End of story, according to Einstein. But he never really believed that quantum mechanics was the true description of the world. And when he was developing the general theory of relativity, he was just thinking about gravity and not quantum mechanics. Stephen Hawking came along in 1974 and started to inject quantum mechanics into our understanding of things like black holes. And that's where Hawking proved that black holes are not completely black. He showed that black holes allow a certain amount of radiation to leak out of their surface, leak out of the event horizon, or leak out from just beyond the edge of the event horizon. And so, yes, when you think about black holes, as far as we can tell, they are a fundamental quality of the world, but you have to include quantum physics to truly understand them, and that's the cutting edge of what's happening right now.
There is a tenet of string theories and a supposed property of quantum gravity that state that the description of a volume of space can be thought of as encoded on a lower dimensional boundary to the region, such as a light-like boundary, like a gravitational horizon. This is known as the holographic principle, and was inspired by black hole thermodynamics, which conjectures that the maximal entropy in any region scales with the radius squared, and not cubed as might be expected. In the case of a black hole, the insight was that the informational content of all objects that have fallen into the hole might be entirely contained in surface fluctuations of the event horizon. The holographic principle resolves the black hole information paradox within the framework of string theory. However, there exist classical solutions to the Einstein equations that allow values of the entropy larger than those allowed by an area law, hence, in principle, larger than those of a black hole. These are so-called Wheeler's bags of gold. The existence of such solutions conflicts with the holographic interpretation, and their effects in quantum theory of gravity, including the holographic principle, are not fully understood yet.
There's now a connection between quantum computing and black holes. But work over the last 20 years has established that when you have a black hole, actually even more general systems, but talk about a black hole, there's an alternate description of a black hole in terms of what's known as the holographic description. It's as if there's a two-dimensional world that surrounds any given three-dimensional world that has exactly the same physics as the three-dimensional world that we're familiar with, and yet it describes it in a completely different language. So a black hole gravity is obviously essential. That's how a black hole forms. But in this dictionary that physicists have developed, there's a description of a black hole that doesn't involve gravity. only involves quantum mechanics. And the beautiful thing is the quantum processes in that quantum world mimic the kinds of processes that people have been developing for quantum computing, quantum error correction code. And there's a dictionary that people have proposed for that quantum language on the holographic boundary with physics in the interior. And the dictionary shows that the quantum error correcting code may be the reason why space-time itself holds together. So there's this bizarre way in which everything that we know about in the world around us has a translated dictionary version in a different world that lacks gravity but has quantum mechanics. And so people are using some of the insights from quantum computing to understand questions about black holes and space-time.
According to a new paper in the journal Annals of Physics, the geometry of space-time around a black hole behaves like a quantum computer, and it can encode photons with quantum messages. Ovidio Ricorian, a researcher at the General Direction of Information Technology in Bucharest, Romania, explained that the distorted geometry of space-time near rotating black holes can create and manipulate quantum information encoded in beams of light that are emitted by, or that pass close to, these black holes. In a theoretical quantum computer, a quantum computation process consists of photons traveling through a setup of mirrors, beam splitters, and prisms that switch the polarization and twisted phase of photons to values that can be mapped onto zeros and ones. The novelty of his research is the suggestion that the geometry of spacetime near spinning black holes acts in an ideal manner to this setup of prisms and mirrors. This means that a spinning black hole writes a quantum code that we may decode in the near future when we come to create quantum computers. He says we are now on the verge of a new technological era, an era that will be dominated by quantum technology. We have legitimately come to create quantum computers. He says we are now on the verge of a new technological era, an era that will be dominated by quantum technology. We have legitimate hopes that these quantum computers will help unveil some of the now hidden mysteries of the universe.
Alright guys, that was me playing around a little bit. I've been studying this shit since I was a kid, like I said. I always wanted to know, everything. Fuck, everything. So I'm going to finish this up. That was the end of that. I told you it was going to be like... Sorry. Told you it was going to be like a little long there. But, I want to know, like, how are they getting this information? How do they know... Well, first of all, they, scientists, and I mean this with the utmost respect to some of the smartest people in the world. How do we know black holes are not solid, or like, I'm sorry, I don't want to say solid, like a liquid state? Think of like a black pool, just like a big circle jacuzzi, I don't know, and it just filled with tar. Like, that's how I kind of think, but then again, I will always thought black holes, it's just a hole you just keep going through, and to wherever it is you go, that's it. If, you can travel without dying, or some special suit, does it take you to another place? I guess we'll never know. Some of yous might be like, well, what's the point in trying to figure this out? I guess that's the point in a way. This does affect us all. You might not think about it on a daily basis. Like, maybe I think about this shit every day. I go to bed listening to this shit. And I didn't just start getting into this, like, because YouTube. Like I told you, since, like, books and shit. If anybody doesn't know what they are, they're heavy things with a lot of words in it. But, I read books, talked to teachers. I was really big on listening. I know that's hard to understand, because if I have like a guest on, I'm doing all the talking. But when it comes to this shit and somebody's saying something that's interesting, I'm like, So, that's the show there. Now, I'm doing this on a Saturday. This might not be released until Monday. I usually do like goofing around shit on the weekends, but you know, I wanted to get a little bit serious for once and stick on a topic, even though I'll probably have a whole bunch of stupid shit thrown into this episode. But I don't know. What do you guys think? What do you think black holes are? How do we get that information? You know, we can only see what our telescopes, and we could see that it sucks in other stars around it, and the mass is there, but we're not going to get close to one, not in our lifetimes, or, you know, it doesn't really matter. I think that's like another show, but on a deeper side, we'll know more as we, you know, grow as a species. And I don't mean that you won't know personally. I think you will know some of these answers. It's just beyond our understanding, and that's the best way I can explain it in the words that were brought to me by my ancestors and so on. So, are we alone? Is there aliens out there? I like to get into that too, but also the thing is, like, I mean, what does it really matter? I mean, I'm not renting out a room to one, or I don't think I am. I mean, what the fuck is an alien? If you really want to get to the nitty gritty, I mean, I know the definition is like, you know, an alien, and I'm not talking about like fucking a Mexican or illegal immigrant. I'm talking about like, you know, these creatures, they're us, just from a different rock around a different sun. That's it. Or star to them, and they probably use different things and way to communication to talk, and I've looked all that up. It's really astonishing, the shit that people say that they've been abducted, and there's people that go around the world and literally study these people, and we're talking thousands of cases that they say, hey, these people get abducted, like it's out of the woods. You know, they get visited, they see this, they say that, and all their stories tend to, all the data all kind of sticks together, and it's the same. And as far as the black holes go, every scientist that studied from, you know, Einstein and before him, and I mean, fuck, I don't know who studied what, Tesla, I don't know. I know he probably had to study something. I mean, he created something, didn't he, Nikola Tesla? Didn't he create like the fucking, I don't know, something about light? Anyway, what I'm trying to get at is these guys had to study, learn off of somebody else, and so on and so on and somebody. But there had to be that first person, man, woman, person, to teach or to better understand, hey, the Earth's not flat, and so on. So that's pretty much it on that part. So I know I ran a little bit long there, but that's just the black holes. I wanted to get into the universe of it, and it's so much. It's, my brain is all over the fucking place. Like, I can go down this road, I can go down that road, but when it comes to it, I mean, I think, you know, this is a good way to keep your brain busy, especially if you have, like, fucking a mental disease, you know, ADHD, ADD, whatever the fuck, any D's or alphabet letter disease people out there who listen to this show on a daily basis or when I drop these episodes. I appreciate it. I hope you enjoy. I know you could probably look a lot of this shit up on YouTube. I try to keep this real, so this is probably going to be on Monday, which would be November 22nd. Today's the 20th when I'm doing this. So, that's it. I mean, I really want to get, you know, dive deeper. So if I add shit to this, I will add shit to this. So for right now, take care of yourselves and one another, and I may or may not put more stuff in. Alright guys, take care. Peace out. This is Jimmy James. A to Z. Come, take a walk with me on the life of life. I fucked the ending that up. I was gonna say, come take a walk with me on my life and your life together, the same universe, the same pattern. What's in it for us? What are we doing here? This is Jimmy James. Take care of yourselves and one another. Peace out.